Good evening. I will share with you my basic observations on the consequences of the two devastating earthquakes of February in Turkey on RC buildings. At the time of our visit, most of the debris of the severely damaged and collapsed buildings were removed, owing to the admittedly remarkable efficiency of the Turkish authorities. Furthermore, some constraints in the results I'm going to present are that that buildings were inspected externally as a rule. Plots and details of the structures were not available, and in general, the period of construction is unknown. Now, typical characteristics of the buildings inspected: the height is over 6 stories, the use is residential, and some buildings have commercial use in the ground story. Some buildings are constructed in cantilever, they're extruded above the ground floor. The ground floor is usually, in some cases, is less stiff than the others because it has less infills and also the height, increased height compared to the upper floors. Reinforced, in general, frame structural systems are adopted. Only few shear walls, we observed a few shear walls compared to frame systems. Flat slabs is a construction system often encountered, either solid slabs or slabs with like the waffle type slabs. And finally, another observation concerns the construction practice used in the infill walls. Either clay masonry was used, and in some cases, also in that part of Turkey, also cement masonry units were used. However, the connection with the reinforced concrete structure was not attempted, and absence of lintels also was observed. And in some cases, even the infills were built completely exterior to the reinforced concrete structure. This resulted in early failure of the infill walls. Now, the building, the design codes in Turkey include strict provisions according to the Eurocodes recently, and in earlier versions, according to the ACI, they were in line with ACI provisions. Here are some provisions from regarding the reinforced concrete columns, the design practices, and here are the dates of the respective codes, and here are the practice for shear walls. Now, some typical comment on typical damages of individual structural elements. In general, damage in the reinforced concrete structure, as is typical in other cases also, occurs in the ground story, especially when the ground story is may be considered as soft story. The damage in the infills is also more intense in the ground story, but also was observed in higher stories because the infill wall was not well connected to the frame, to the reinforced concrete structure. Now here, some typical damage of concrete columns was the opening of stirrups or the sparsely spaced stirrups, which resulted in buckling of the longitudinal reinforcement. Also, because of congestion of longitudinal rebars, there were some cases that we observed inadequate compaction of concrete. Now, damage in reinforced concrete walls, not much damage was observed in shear walls in newer buildings, contrary to older buildings, perhaps owing also to lower concrete strength. This is a damage that occurred when, because of the subsequent to the failure of masonry walls, because the part of the column revealed behaved as a short column and shear failure occurred. In case of reinforced concrete joints, when the stirrups were present and well closed, no problem occurred. Contrary to the to when absence of stirrups, where in cases of no stirrups in the joint or stirrups that were not adequately closed and opened. Damaging beams was not often observed, and when it was observed, it was attributed in different reasons different than flexural failure. This type of failure in beams was caused by a seismic joint which crossed the beam, which was the joint was not vertical. Now, some comments on the behavior of flat slabs. This building in Gölbaşı had flat slabs, this filler joist or waffle slabs, which behaved very well, had no damage after, showed no damage after the earthquake. In some cases, however, these type of slabs result in large deformations in the slabs. And also, in case not adequate lateral stiffness is provided in the structure, because no beams are present, failure at the top of at the ends of the columns may occur. Now, this is an interesting, let's say, interesting example of a failure of a similar, of a building with similar slabs. It was one of the few buildings that were had collapsed and were not removed at the time of our visit. So in the week, all the columns had a direction, are directed in with the weak direction in the are situated with the weak direction. They're weak. They were in the weak direction along parallel to the earthquake, which resulted in collapse of the building, and the collapse of the building resulted in serious damage to the adjoining building. This building is building A, this is building B. So we can see here that although the distance between A and B was big, there was a road here between the two buildings. Both buildings were removed according to this picture on Google Earth. Now, some comments regarding the behavior of buildings, global behavior. Here is a collapsed building, a soft story. One story, this ground story is missing, probably because of inadequate stiffness. Here is an example of 4 similar buildings in Adıyaman, A, B, C, D, constructed at the same, more or less the same period. We can see here that all buildings had masonry infills in the ground story. However, after the earthquake, all masonry infills at the ground floor, practically all, were damaged. And as a result, damage was observed in the columns of the ground floor. In buildings in which shear walls were present at the perimeter of the building, the extent of damage was less. So the importance of the masonry walls as a non-structural system, but as a capable of resisting lateral forces at the first stages of earthquake is important. Now, this is another complex of buildings in Adıyaman. This, I think, is the photo in the program of this webinar. partial collapse, one of the six building complex. One of the buildings showed a partial collapse. This is the same collapse, but from the back part of the building. Now, these buildings had a flat slabs system. This may not be, of course, the cause of the collapse, because similar buildings, only this building had serious damage and collapsed. Other buildings behaved well. Now here is the plot. So the buildings were constructed after 2015. And here is the building which had this partial collapse, and it was demolished after June 2023. Another important issue and observed in this specific earthquake was raised also by Professor Sextos, is that damage caused by collapse of adjacent buildings. Here is one building in Islahiye, and we can see that all this damage is caused by the collapse of adjacent buildings. And usually this type of collapse occurs in buildings which have a considerable distance between, they are not in contact, but a considerable distance between the building that collapses. So here this is at the time of our visit, but before the earthquake occurred, 3 buildings were present on the left of this building. Here is another building in which the slabs here were crushed because of the collapse of the building in front. This is building A. Here's building A. Building B collapsed. Although the distance, you can see there's a road here between the 2 buildings. However, this building collapsed, fell here, and crushed the slabs of building A. And here is the building B, the part of building B, the building C, the remaining building C. And finally, this is another case of a building which was constructed before 2008. It has a regular layout in height and in plane, and no damage in these along these faces. But here we have damage. Damage is caused by the collapse of adjacent buildings. What is interesting is that the detailing of the rainfall of the concrete members here was very poor, sparsely spaced stirrups and not particularly good concrete strength, as we can observe. However, the masonry walls stayed in place. So the good performance of this building, despite the great impact of when the other building fell on this building and caused this damage, may be attributed to the resistance offered by the infill walls. And here is this was building, I think, building A, building B and C. So building B and C collapsed and caused this local damage to building A. And here is the damaged buildings B and C. And to conclude this presentation, I would like to show you a picture of how a lively neighborhood in Kahramanmaraş was before the earthquake, and what happened. What is the picture after the earthquake? The only building standing is this small building here. This is the end of my presentation, and I would like to express my acknowledgement to the organizers and sponsors of this mission who enabled my participating in this really impressive and deeply instructive mission, and also to Lambros Kouzelis, PhD candidate, for providing the building data from Google Earth.